Welcome back, students. In this video, this is the last video for the text we're covering. So this is Module 11, Topics 6 and 7. Volume of prisms and pyramids, cylinders, cones, and spheres. These topics, the standard is GR 4.5. Solve mathematical and real-world problems involving the volume of three-dimensional figures limited to cylinders, pyramids, prisms, cones, and spheres. So we have 5 different shapes. We're going to talk about volume only. All these formulas that we're going to cover are on the reference sheet for our end of our EOC test that's we have coming up. So that's the good news. You don't have to remember these formulas. The bad news is you're going to have to remember all these little tricks along the way, but I'm going to show you, and hopefully we'll all get there together. So this is page 16. This one's going to be a little bit. It's 6 pages, although 2 of these pages, it's really just half a page because of the spacing and stuff. We struggle sometimes with the formatting on these documents. So, page 16. No warm-up. This is let's go straight into the lesson. So let's get going with it. So, volume of prisms. So that's our first shape we're going to start talking about here. Recall that the volume of a solid is the measure of the amount of space that the solid encloses. Dadgummit, I forgot those shapes again. God, this lesson is so much easier with the shapes. I may have to go back and redo Module 11 with those shapes later, but not now. That's a summer project. Alright, so volume of a prism. So the volume V of a prism is V equals B, the capital B, where the capital B is the area of the base, and H is the height of the prism. So the area of the base, and then you figure out that, and then how tall it is, that's how much it would cover. It would be to fill that up, whether you're talking water or whatever. Scooch up here a little. Alright, so next little, they touch on this, and it's not a big thing, but, and I don't think we have any examples or anything we use this, but it's included, so we'll talk about it real quick. So, Caliberi's principle. If 2 solids have the same height, so these 2 are the same height, they look different, and the same cross-sectional area B, so your base is the same, then they have the same volume. So I said I don't completely understand it, and that's really all they give us, so I'm saying it to say it. Let's get down here to the math. So, find the volume of a prism. Alright, on the left here, so we have a pentagonal prism. So 5 sides, you see they're all congruent. So we're going to need the perimeter, so let's start with the perimeter, which is the number of sides. And here, pentagon is 5, and the side length, that's your S. This is the apothem. I'll explain in a moment, but I'm labeling, and this is the height, because it's showing how tall this is. So this is our H. The apothem here, that is from the center of that pentagon on the base. It's perpendicular, and if this was in a circle, that would go to the edge of the pentagon, not the circle. That would be how I would differentiate, but here it just goes there. We have the red box, so we know that it's perpendicular. But this is the apothem. We're going to need it to get the base area. So let's start up here. Let's do this. So middle of the page, I'm going to say my volume is my base area times my height. I was trying to point, but it's beyond where the screen's at. But first, we need the base. So for this pentagon, and we learned back in the previous module that for a pentagon, area of that base is the 1/2 of the apothem times the perimeter. And I'm going to need to go back here and finish the perimeter. 5 times 5 is 25. So there's your perimeter. Okay. So that's why we needed that apothem, and they did that for us so we wouldn't have to mess with the central angle, and they could have made it a lot harder on us. So 1/2, 3.4 times 25. We multiply all that out, and our base area is 42.5 millimeters squared. Millimeter squared because it is area. Alright, so down here we have the height of this guy. He's 8. We now have the base area. That's 42.5. We multiply those together, and we find out that the volume of that pentagonal prism is 340 cubic millimeters. Okay? Alright, well, these guys aren't numbered, so to the right. Find the volume of the prism. So, let's see. So you see it's triangular, it's a right triangle. Let's see first, so, and this is the base, so we can see it. This is the height, okay, because this is the base, so that's how tall it is. So you see we have this triangle, this is the base, we need this, it's because it's 1/2 base times height. This is the height of the base. This is the height of the prism. So this is how tall the prism is. This is the height. It looks worse than I thought, of the base. So we need this side. So we have a right triangle here. It's easier if I draw it here. So it's 9 here. This is the same as this, so that's 15. We need, this is a little h for, let me do this, hold on. So we're going to do volume is base area times height, and then down here we're trying to get our base area, which is 1/2 base times height, because it's a triangle. But over here in pencil, so we have across from our 90-degree angle, that's the hypotenuse. So it's c squared minus, we'll just say b squared equals h squared, or, you know, a. Just so you guys don't get confused. So c squared, 15 squared minus b squared is 9 squared to get our h squared. 15 squared is 225. 9 squared is 81. Subtract those from each other and you hit 144. So that height squared is 144. We take the square root of both. Square root of 144 is 12. So the base height is 12. Let's go over here. 1/2. We just got 12. Well, I put it in the wrong spot. That's the base height. This is the base, which was 9. Yeah. Multiply those out, and our base area is 54 square feet. So remember, volume is cubes because it is essentially, well, yeah. So forget the half, but it's units times units times units, because these two made that. So, and then area is just units times units. So units times units. I know, I confused you. Sorry. Alright, so now, base area, 54. Height, it's 10 feet high. So volume is 54 times 10, which is 540. And this is cubic feet because it's volume. Alright, let's flip over. Page 17. On the left, find the volume of the oblique prism. Sorry, I had to switch paper. Alright, so first thing we need to notice, the base. So I'm just going to write base. That's the base. So this is the height of the prism. This is the base. So the base is a trapezoid. Trapezoid base, and I'm just calling it capital B because our volume is base area times height. So I'm trying to make this trying to uncomplicate it as much as I can. So area of a trapezoid it is 1/2 of the height times base 1 plus base 2. So let me explain before I start showing you. So the trapezoid, the base 1 and base 2, remember the sides that are parallel are the bases. That would be these two. So 4 and 2. 4 and 2. The height of the base is right here. So height of base, and I know it's way too small. I promise I'll get better at this, guys. Alright, so the height of the base is 5. Alright, so 4 plus 2 is 6. Times 5 is 30. We're going to take half of that. Half of 30 is 15. So our base area for that trapezoid is 15 square centimeters. So we plug that in. And then the height of the prism is 8. Multiply those together. Our volume for this guy is 120 cubic centimeters. Something real quick. I don't like that mouse being so close to the stop button because it's too much. Alright, to the right. So I'm going to give you the formula on this one, and I'm going to let you plug it in. I'm going to show you. So, you know, we know that that's a prism. So it's base area times height. Well, this is also because the base area of this square or rectangle, whatever it'll be, you can still break this down, is length times width, and then the height. So for this, the height is here. That's the height of the prism itself. This is your length and this is your width, or vice versa. Hold on, let's do it this way. Okay. So we plug it in this way. Well, never mind. I gave you enough. Plug those in and give me the volume. Sorry, I get in teacher mode. Alright. Middle of page 17. Volume of a prism using algebraic expression. Gustavo wants to calculate the volume of juice in his juice box in cubic inches. I'm not sure why he doesn't just look at the back of the box, but anyway. But that's why we're here, to do the math. Part A, find the volume of the juice box in terms of x. Part B, we want to find the volume if x equals 2. So we're going to basically have an equation here, and then we're going to plug in 2 into x over here. So part A, volume is base area times height, or in this case it would be length times width times height. This being your L, this being the width, and this being how tall it is. Okay? So length is x, the width is 4x, and the height is 4x plus 3. Now, I'm going to break this down a little further than the ones I'm going to do in going forward, but so x times 4x is 4x squared, which would have been the base area. I just cut that step out for the purpose of the video. Now we're going to do 4x squared times 4x plus 3. So we combine these two and got this. We brought that down. 4x squared times 4x, I'm just going to put parentheses, I don't know why I did that, but 4x squared times 4x is 4x cubed, plus 3 times 4x squared is 12x squared. So this is our part A in an algebraic expression. Part B, and again, I'm sorry for the camera. I'm going to see if I can get a hold of the IT guy tomorrow. I want that other app that we use for this camera. It's just better. So we're going to take that expression down here, 16x squared plus 12x, no, 16x cubed plus 12x squared. Now we're going to plug in 16, so x equals 2. 2 cubed plus 12 times x. That's x. X is 2 squared. Okay, so 2 cubed is 8. Plus 12, 4 squared, I'm sorry, 2 squared is 4. Multiply 16 times 8, 12 times 4, add them together, and you get 176 cubic inches. Alright, bottom of the page. So we're going to talk about pyramids. We're going to flip over and work a few. Volume of a pyramid. Volume of a pyramid is V equals 1/3 base area times the height. Oops, sorry. So base area is capital B, and the height, that being the height of the actual pyramid. Okay, so 18. I've already written this because I want you guys to do this one on your own. So the volume of this pyramid, I've been doing this one wrong all day. Hold on. Oh, no, I just forgot to write the 1/3 in there. Whew. Tried to do this beforehand. Alright, so volume equals 1/3. Let me just do it over. 1/3 base area times height. Okay, so there's your formula. Here's the height of this guy. They give you the base area, so you don't even have to work that. So all you're doing is multiplying those two times 1/3. I'm going to scoot down the page, and we're going to work this one together. So volume of a pyramid using algebraic expressions. Martin bought a bank shaped like a square pyramid, and he wants to calculate its volume. Part A, we're going to calculate it in terms of x. In part B, we're going to plug in x equals 4 and get the volume. So I'll write this one in blue. I think it might look a little better. Alright, so part A. Find the volume. So we're going to start over here, and then part B we'll do it over there. So part A, the first thing we got to do, because the volume is 1/3 base area times height. So we need the base area. The base of this is a square, so it's 8x. You know, base area for that side squared or side times side. So each side's going to be congruent, so it's 8x times 8x. 8x times 8x is 64x squared, so that is your base area for our pyramid. So now we plug that, so we have 1/3 base area, 64x squared, and the height is 5x. No, wrong, hold on. We have to calculate that over here, so give me just a moment. I'll do the best I can. So 5x is the slant height. We have to draw an altitude here. So from the vertex into the base, it's perpendicular. So what we essentially have is you guessed it, a right triangle. The slant is the hypotenuse, which is 5x. Notice, so this splits the side in half. So each side, half of it is 4x, and half of it is 4x. 4x plus 4x gives us the whole side. So we have, so this is going to be the easiest Pythagorean theorem you had. So c squared is 5x squared. This guy is 4x squared. Subtract them, you get x squared. What's the square root of x squared? It's x. We needed that because that is the height of this. So now, back over here, 64x squared times x. And we know why over here. So this is the part A. part B, we plug this in. So X was 4. Alright, so we have 1/3 of 64 times 4 squared. 4 squared is 16. I'm just going to put all these down here. Times 1/3. Just make that a little better. So we bring that up. We do all the math. Where did I go? It's 1,365.3 cubic inches. Trying to get that so we can see here. Alright. Alright, so here I'm going to do part A and B. Part C is you're just adding them together. So here. So you guys do that. But we'll do A and B together. So part A, so we have a composite solid. It's this pyramid up here and it's this rectangle. So we're going to find both of those and you guys are going to add it together. So part A, find the volume of the prism. Volume of a prism, base area times height. So for the prism up here, they're both of these. So the base area of a square is side squared, so 6 squared is 36. And that goes for both of those, part A and B. So over here, base area 36. The height, so that's where it gets complicated for the prism. No, sorry, the pyramid part. The prism, it's 3. That's the height. Prism. Up here we're going to have to get special with that. So 36 times 3, our volume of part A is 106 cubic inches. Alright, part B. So this is the volume of the pyramid, which is 1/3 base area times height. We have the base area. It's the same for both of them. It's 36. Now, the height of the pyramid, that's where it gets dicey. So we would draw our line from our vertex into our base. It's perpendicular. It's a bisector, and it's a right triangle, because that's our favorite. You see our slant height, or our hypotenuse, is 5. This side is 6. Half of it is 3. Because remember, it splits it in half, so 3 and 3. We're looking for the altitude. We're just going to say x. So 5 squared minus 3 squared, because this is the hypotenuse. Hypotenuse minus the one side. So 25 minus 9. X squared is 16. Oh, we're off the screen. Alright. Square root of 16 is 4. So our height of our pyramid is 4. So 36 times 4 divided by 3, because we want 1/3 of that. The volume for that guy is 48 inches cubed. So now you guys are going to take and just add those together. I am going to move on to page 19. I said halfway down the page. Volume of cylinder. The volume V of the cylinder is V equals base area times height. Or, so because that cylinder is a circle, we can replace the base area here as a circle, so you can replace B with pi r squared, because that's how you find the base area for a circle. So I tend to just go this way because it's the same thing, and we just need those two numbers. The radius they usually give us. So, yeah, path of least resistance, folks. That's what we're looking for. Alright, so, hold on, microphone down. Alright, so approximate the volume of a cylinder. So Andrew wants to mail his brother a collection of antique marbles. He needs to calculate the volume of the mail tube before he buys it to ensure that it will hold all the marbles. Find the volume of the mail tube to the nearest tenth. So, volume equals pi times the radius squared times the height. So remember, our base is here, and our bases are on the top and the bottom, so this is the height because it's turned on its side. So pi, radius is 1.25, and the height is 10. Multiply those, squared, 1.25 squared. Multiply all those out, and the volume is 49.1 cubic inches. Alright, let's get down to the bottom. Sorry for the weird screen. It's because my arm is in the light. Okay, bottom of page 19. Find the volume of the cylinder with the radius. So they're telling us here in the problem. I mean, you can see it, but they're telling us. But I like to write this down. So, radius, so the r is x minus 5, and the height is x. But again, they show us over there. I like to write it down. Part A, find the volume in terms of x and pi. So for A, I'm going to do it like this. So the volume is equals pi r squared times the height. Pi, what did they say? Oh yeah, x minus 5 squared times the height is x. Now, we can break that down further. Well, I'll tell you what, let's break it down one more. So, we got pi here. So, x minus 5 squared. So it's the same as x minus 5 times x minus 5. So your first are your x's, so x squared. Your outer is negative 5x. Your inners are negative 5x. So negative 5 and negative 5 make negative 10x. Oh God, I made this more complicated than it should be. And then negative 5 times negative 5 is a positive 25. And we have all that times x. I'm not going to break it down any further. That's going to be where we stop because we're just going to plug in x equals 8. And it's late. So part B. So the first thing I do, I take that expression. I don't know that they ask something like this on the EOC, but if they do, just try to work it like this and then plug your x back in. Just make sure you remember all of them. So pi times, what is x? 8. So 8 squared minus 10 times 8 plus 25, all of that times 8. Multiply all that stuff up. And yeah, it was much easier over here with this. You just plug it in and you end up with pi times 9 times 8, or 72 pi. It's 226.2. So just trust me, this is right. That's a little squirrely. Alright, page 20. Last two pages. Try to hurry just so we don't have such a long video. So again, Calaveri's principle, you can take a pyramid and a prism. They're shown to have the same, because they have the same base area, B, and the same height, they would have the same volume. So I don't know. Anyway, so the volume of a cone. So our next, we're almost done with shapes here. Volume of a circular cone is V equals 1/3 of the base area times the height, or because the cone has a circular base, you can substitute base area with pi r squared. So you can use volume equals 1/3 pi r squared times the height. Again, r being the radius, but hopefully we know that. If we don't know that, we're in some kind of trouble, folks. But I think you guys are going to do great. Okay, oops, sorry. Alright, volume of cone on the left. Part A, find it in terms of x and pi. Part B. So I'm not going to get too fancy here. Volume is 1/3 pi r squared times the height. So our height is here, our radius is here. So we plug this in, 1/3 pi, radius is x minus 1 squared. The height is 3x minus 5. Not squared because it's the height. I could go further. It's just easier to do it this way, because I care more about finding the volume than I care about that. Most of the time we're going to have a number here. So this is just working on our algebra. So volume equals 1/3 pi times x minus 1 squared times 3 times x minus 5. Okay? And they want x equal 4. So 1/3 pi 4 minus 1 squared times 3 times, oh yeah, x is 4 minus 5. 1/3 pi. 4 minus 1 is 3 squared. Let's do this. And then 3 times 4 is 12. 12 minus 5 is 7. 3 squared is 9. See how much easier that is? And then we have the 1/3 pi. And then the volume ends up equaling. Can we still see me? I can't see the screen. Yes, okay. So multiply all that out, and we get the volume is 66 cubic feet. To the right. So I'm going to give you the formula, which is the same as this. It's just the volume is 1/3 times pi times the radius squared times the height. So notice we don't have a height. This is a slant height. We have a diameter, and I advise you to write, so the diameter is 10. What's the radius? It's half of that. It's 5. So let's bring this down. We have the radius. It's 5 squared. And then now the height. That's what I'm going to help you with, and then you guys are going to plug in the height there and finish off the volume. So we have go from that vertex, we draw our little dotted line. It splits our base in half, which is the same as the radius. It's a 90-degree angle, so it looks something like this. So up here's 5, that's half of 10. Notice our hypotenuse again is 15. We're looking for x. 15 squared minus 5 squared equals x squared. 225 minus 25 equals x squared. So x squared equals 200. So we take the square root of both of those. X equals, it's 14.1 when we take the square root of 200. So plug in 14.1. You know what? I've already done that. All that. Let's just finish it. Multiply all that out. It's 370.2 cubic centimeters. So you guys aren't even here, and I'm talking to me and stuff. All right, last page. Alright, so volume of spheres, and this is actually probably the easiest stuff. They're going to complicate it with this, trying to explain the formula, but I'm going to go with it. So suppose a sphere with a radius r contains infinitely many pyramids with vertices at the center of the sphere. Each pyramid has a height of the radius r. The sum of the volumes of all those pyramids is equal to the volume of the sphere. So I have that each of these pyramids, they have volume equals 1/3 of the base area times the radius. All that equals out to what they show us here. So the volume of the sphere, I'm trying not to put my hands in front of the camera, but what's highlighted. So the volume of the sphere is 4/3 times pi times the radius cubed. So that's the only place we cube the radius, so I'm hoping I can drive that point home to you. So, alright, so we're going to scooch down. We're going to approximate the volume of a sphere. So a chocolate company, they want to create a bite-sized, individually wrapped, solid chocolate sphere. The diameter of that sphere is 1.5 inches. Find the volume of the chocolate used to make the sphere to the nearest 100. So our volume is going to be 4/3 times pi times the radius cubed. So 4/3 pi. So the diameter is 1.5. That radius is half of that, which is 0.75. 0.75 cubed. So when you multiply 4/3 times pi times 0.75 cubed, we find out that chocolate is 1.77 cubic inches. So about about that big, or a little bigger than what's over there. Sorry, I didn't mean for that to jack with the camera so bad. Okay, bottom of the page on the left, examine the sphere. Find the volume of the sphere in terms of x and pi, and then we're going to plug in 2.2 for pi, for x, and give the volume. I'm going to do that for over here. I'm going to give you the formulas, and then you're going to add those together for our composite shape. Let's go over here first. So part A, the volume of this sphere is 4/3 pi times the radius cubed. So it's 2x plus 3 is our radius. 4/3 pi times 2x plus 3 cubed. I'm not going back to algebra for all that. We're gonna call that our algebraic expression, and I'm gonna plug it in here in part B. Except I'm gonna do it in blue. Blue for all you Gator fans, and as we get ready to go into the Final Four. Sad to say Alabama couldn't get past Duke, so good luck to you guys. Alright, so 4/3 pi 2x plus 3 cubed. And they said x equals 2.2. So it's 2 times 2.2 plus 3 cubed. When we do all that math, the volume is 1,697.4 cubic inches. And I can tell you this looks like a basketball, but I think that's a lot. I don't know. Maybe it's not. Maybe it's not. Curious what. I have to look that up. Alright, on the right. So again, I'm going to give you the formulas. So we have this cone and we have the semicircle, or half a sphere. Half sphere, we'll say. I don't even know if that's right, but we'll say half sphere, and then this is a cone. So the volume for the cone is 1/3 times the base area times the height. It's also 1/3 times pi r squared times the height. Because remember, that's a circular base. This is the same base. They have the same bases, okay? There's your hint. Now for your half sphere, you're going to take the volume of the sphere, which is 4/3 pi r cubed, and you're going to divide it by 2 because it's half of a sphere. This is just, we'll say, volume of half sphere. Once you get those, your total volume is going to be your volume for your cone plus your volume for your half sphere. I'll let you guys work that. Make sure there's nothing funky here. No, this is your height for cone, and the radius, this is the 8 is your radius for here and for here. Alright, that's it. I will be posting a video later, not tonight, but later on pretty soon with the calculator. I keep promising. Trying to do some basics, just try to get you guys ready for that test. If you have any questions, let me know in class. Until then, have a good night.